Today we start working with how to graph sine and cosine, and you've spent a bunch of time working with our bow tie method of finding the trig function of any angle. And the last assignment I had you do was to list all of those values for the sine and cosine functions. And one of the things that you saw was you saw some values showing up over and over again. One of them was 1/2. What's the decimal value of 1/2? 0.5. Now on your calculator, one of the other values you saw show up a lot was radical 2/2. If you punch that into your calculator, if you take the square root of 2 and divide it by 2, you get a decimal, and isn't it 0.707? All right. Let's do that with another value that shows up a lot, the square root of 3/2. If you take the square root of 3 and divide it by 2, I believe you get 0.866. And those values, along with 1 and -1, and the negatives of all of these, show up over and over again. And the reason for that, as I mentioned a minute ago, we'll write in the form of note. These values show up over and over again because the trig functions are what we call periodic. And by periodic, we mean that they repeat the same pattern over and over again to infinity. We're going to see in a minute that the sine function keeps doing the same thing over and over again from negative infinity to positive infinity. And it keeps repeating those same values over and over again. Now, what I want you to understand next is the connection between those radian values and the x and y coordinates. You remember when we defined a radian, we said a radian actually measures arc length. Like if my measure is pi/6, we're saying that this measurement right here is pi divided by 6. And if I went up a little bit farther to pi/4 up here, then I could say that this measurement is pi divided by 4, 3.14 divided by 4. And we could keep going, on up to pi/2 and say that that measurement of that arc is pi divided by 2. Well, if we take these arc lengths all the way around, if I take pi/6 and I unwrap it, think of taking a coil like a belt. If you take your belt off that's around your waist and you lay it flat on the ground, that is where we get our x coordinates for the graph. I'm going to see pi/6, and I'm going to see pi/4, and I'm going to see pi/3, and I'm going to see pi/2. All of those values that we saw that go around the circle are now going to be unwrapped and laid down on our old friend, the x-axis. Now, this is important because if you try to graph the trig functions on your graphing calculator, you must be in radian mode for this very reason. because all of these x values are radian values when we graph it on the xy coordinate plane. All right? So, on Friday, we learned that the sine of pi sixth is 1/2, right? Now, so let's just kind of mark this on my graph. Here's 1, down here's -1, and here's 1/2. So the sine of pi sixth is 1. Now, I don't know if everything's going to be perfectly to scale, but this is going to give us an idea. The sine of pi sixth, we said, is 1/2. You found that out. And then we said the sine of pi fourths was radical 2/2. Well, so didn't we say that radical 2/2 is about 0.707, right? So I come up a little bit farther to here, and that has the coordinate of pi fourths radical 2/2. There's the coordinates of that one. This one has the coordinates pi fourths 1/2. And then on your chart, we found that the sine of pi thirds is radical 3/2. So we're going to come up even a little bit farther, which is the sine of pi thirds is radical 3/2. So when I come to pi thirds, this coordinate is pi thirds radical 3/2, and we just did the decimal form of that a minute ago and said it was about 0.866. And then we know that the sine of pi halves, that's one of our corners, is 1. This coordinate is pi halves, and that's 1. And somebody caught my mistake over here. This is supposed to be a pi sixth, not a pi fourths. So if you look, now by the way, what is the sine of 0? It's 0. That's one of those corner values. Now, I want you to look at your chart, and let's go to the next value after pi halves. What's the next one on your chart after pi halves?
2 pi.
It's the sine of what? 2 pi thirds. So if I go to 2 pi thirds, what is that value? Should be radical 3/2. So look, we start coming back down now. The sine of 2 pi thirds, well, that has coordinates 2 pi thirds, radical 3/2. And we can start to see the sine curve take shape. Now let's kind of add a point over here. The sine of pi is what? 0. So that point, it comes back down. And so we see the sine curve starting to take shape from all of those bow tie values that we've been working with. Now, it keeps on going, and of course over here we get into our negative values. Okay? And so we find out that when we get from pi to 2 pi, it's negative. And so the basic graph of y equals sine of x is drawn like this. One period is 2 pi. And we use what is called, you know those corner values that I called them corners? In the math world, they have a more special name called the quadrantal values, quadrant values. Watch how easy this is. What's the sine of 0? 0. What's the sine of pi halves? 1. The sine of pi is 0. The sine of 3 pi halves is back down to -1, and the sine of 2 pi is 0. And that right there, that is one period of the sine graph. Okay? So let's make a note. One period of y equals sine of x is 2 pi. And all those other little values that we used, We don't have to use those all the time, but we do need to know how to find them. All right, that's why we spent all that time doing it. We do need to know how to find them. But when we graph this, we're just going to use the quadrant values. All right? And the nice thing is, cosine is just like sine, but it's what we call out of phase. All right? Cosine, I'm sorry, that's supposed to say cosine. Cosine of x is just like sine of x. It still has a period of 2 pi. We still use those quadrant values just like before. And if you remember what those quadrant values are, for cosine, it starts at 1. The cosine of 0 is 1. And it goes 1, 0. The cosine of pi halves is 0. The cosine of pi is negative 1. Okay? The cosine of 3 pi halves is back to 0. And the cosine of 2 pi is back to 1. So there is my cosine graph. And it is just like the sine graph. You saw all those same values showing up over and over again. But it is, this is how we graph the cosine function. We graph it from 0 to 2 pi. But just to help you understand it, cosine is exactly pi halves behind. Okay? So we would say, note, y equals cosine of x, I'm going to say follows the same path as y equals sine of x, but it is pi halves behind, or we would say out of phase. It is exactly the same graph. It just happens to be slow. Okay? It's pi halves behind. But again, I want you to note that when we graph this thing, we're always going to work between 0 and 2 pi. That's how we're going to graph these things to start. All right? Now, one other thing real quick to help you deal with homework tonight. And this is very easy. Your homework tonight is going to be very easy. Note, for y equals a sine bx and y equals a cosine bx, the period is p equals 2 pi divided by b. Now I know what you're thinking. I thought you just said, Mr. Lindner, that the period was 2 pi. Well, it is if I have a 1 in front of the x. But I don't always have a 1 in front of the x. All right? The period is 2 pi over b, and the amplitude is a. Now, I'm not sure, it depends on how much science, what you've covered in your science classes, whether you've seen this or not. But the amplitude, so you know, is the height of the curve. This is what we call the amplitude. All right? So, for example, let's say that this was 1, 2, 3. We would say that the amplitude of this thing is 3. It has an amplitude of 3. All right? So tonight, they're going to give you, it's going to be very easy. They're going to say, find the period and amplitude. And they're going to say something like this. Y equals 4 sine of 6x, something like that. Find the amplitude and the period. Well, what's the amplitude? 4. The amplitude is 4. Boy, that was hard. How about the period? The period is always 2 pi divided by b. Well, b in this case is 6. So the period is 2 pi sixths, which we can reduce to pi thirds, which means for that particular sine function, the period is much shorter. And we're going to talk about how that impacts the graphs later. One little thing that I know might become a question, what if I had this one? Y equals -2 sine of 3/4 x. Well, the amplitude is -2. That's easy. But the period is 2 pi divided by 3/4. Well, you just have to remember how fractions work. When I divide by a fraction, don't I multiply by the reciprocal? So you have to multiply by the reciprocal to find the period. So this period would be 8 pi thirds. And we will stop there for today.